Alors, messieurs, dames, ladies and gentlemen, dear friends and colleagues, first of all, I'd like to thank Edouard Bard for convening this really very promising meeting among friends in a friendly atmosphere, even if highly controversial, I think. And at the same time, I'd like to thank Peter Dimendokal also for working as a co-convener of this meeting, and I'm really looking very much forward to our discussion. So I'll talk about geoarchaeological and geological data sets from the Eastern Sahara and compare them to most of all Peter's earlier work. And so it doesn't work, or do I have to use another one? Which one to forward? And well, the Sahara, the by far unrivaled warm, hot desert of the earth. And well, of course, on one side, there is no Sahara. It's a subcontinent. It's now more than 1/3 of the African continent. So comparing it about the surface of the US, you can see it's difficult to talk about the Sahara because the Sahara doesn't exist. More or less because there's big differences, say, between the Canadian border and southern Florida and California and the northeastern states. So one has to be cautious to talk about the Sahara, and because even there's a big gradient from west to east. So if you see at the same latitude, 24 degrees north, it looks like this in the Western Sahara still today, and it looks like this in the Eastern Sahara. There's a big gradient, and probably the Western Sahara is still as humid as used to be the Western Desert of Egypt during the Holocene optimum. On the other hand, of course, the Sahara remains a relatively homogeneous belt, area or big region of subcontinental scale compared, well, to most other continental areas on Earth, such as Europe. And the Eastern Sahara, where I had the luck to work for the past 35 years, it used to be the least explored part on the planet, I would say, at least on the continents. And one lifetime is not enough to know it. There's discussion that means even 60, 70 years ago, there was hardly anything known about this region. And since the late 70s, we had in several long-term projects a lot of field work, many, many years in the field. And each of these dots can represent one day or several weeks, in some cases, several months. And why go there, as we have all these beautiful records from the ice cores, from the marine cores? Why taking this effort? Of course, well, it's not always the same story. And the story of Greenland and Antarctica does not have to be the same as the climate evolution on hypercontinental regions such as the Sahara and on the continents where people used to live and will live. So it's good. And you know this former famous paper which claimed that the Holocene is a very stable period. If you look into the Sahara, you will see that was not the case. And so terrestrial paleoclimatology, I think, is important. And it compared to the funds which went into the marine and Arctic research, we are working really on a much, much lower level. And it's still a difficult work, but you see even on this cover of Ray Bradley's recent book, you can see in one picture the change from the period in the Sahara when there were cattle and then when the camels came, and there's even some more layers if you look closer. So the big discussion more or less started now almost 15 years ago with Peter's epic paper in QSR, which still rates among the most cited papers on the Sahara to the present day, and where he wrote at the time, well, you can read it yourself, around 15,000 there was an abrupt onset, and at around 5.5 there was, again, abrupt ending, termination of the humid period in the Sahara. And at the same time, well, it looks from the core he's been analyzing from south of the Canary Islands as it happened very, very quickly within decades to a few centuries. And in this recent comment by Edouard Bard in last year's Science, again, he is stating the emphasis of this core for the North Africa especially. And he was commenting a paper by Jess Tierney and Peter working on the alkane plant waxes, where we certainly will hear more later. And he was also stating that it's difficult to reconstruct the rainfall changes during the Holocene, and he was asking for more continuous records, which are needed, and the same, to compare, the small Lake Ewa record, and, as you will see, the lake is small, but maybe information is quite big. So as I've been expecting a very mixed audience, so I've been including some papers just to show you our working conditions. Sometimes it takes weeks to reach our study sites, starting in Cairo, working in the northern Sudanese desert, weeks off-road, there's no even dirt tracks. Sometimes you have to drive down quite sharp slopes. Sometimes it takes one day just to reach the plateau from there, and that was the only ascent, so a whole day which you will need to make your own highway just to get the cars up. Sometimes you have to take away a dune just to find a descent from some plateaus. Sometimes the whole fleet gets completely stuck in the Great Sand Sea of Egypt like this, and sometimes if you got stuck 50 times in a row with one car, so you had your sports for the whole day. And even worse is if a 26-ton truck gets sunk in some Sepka deposits, which is like greasy oil, and this took 2 days just to get this and the two Unimogs out. And sometimes, again, you have to construct your own highway just for a big descent from the Erdi Mar Plateau, which is probably the least known part of the Sahara in the northeastern corner of Egypt. And you don't know when you do it and you go down whether there's a way out, because it could be blocked, and even the best remote sensing data won't help you if there's a really just escarpment of a few meters. There's no way to get down with cars. Or sometimes it gets dusty. We are always very happy when it gets dusty, because these are weathered, so-called fesh deposits, weathered early Holocene lacustrine deposits, which we like. That means a second later you wouldn't see the car, and 10 minutes later you wouldn't see the sun anymore if you're in the car. But that's, for geologists, it's good. If you get stuck, that's less. Sometimes, just to mention the uncounted mechanical problems we have, sometimes the whole back axle of your Unimog is cut 150 kilometers west from the Nile, and so you have to use the backhoe, the excavator, to make the last 50 kilometers walking. And sometimes, you don't see too much, like in the Arc de Chorap, or this is a picture from Chad, where you spend 1 week driving, crossing dune area with a site like this of just a few meters. And again, the biggest problem I want to talk about is security. It never has been so difficult and dangerous to work in the Sahara as these days, and there's no outlook for better situation. These are landmines which occur in several areas where there were civil wars, and so that's the worst case happened, but, the passengers, they survived without big problem. Of course, it's very hot during daytime, temperatures reaching up to 50 degrees Celsius in the shade, but of course there is hardly any shade. So you're always very happy when the sun goes down and you find you do your camping in the night somewhere like in this big volcanic dunes, and in the night it gets very cold, so down to -8 degrees Celsius, and with strong winds, with the chill factor, we arrive at a felt temperature of -20, which is really cold, and that's specifically in December, January, in these continental places in the Sahara, very bad. So now about our instruments, our methodology. I mean, what we did most during the past almost 4 decades, that was digging holes, hundreds and hundreds of holes all over the Sahara, and like here in the Great Sand Sea, or here in what we call the West Nubian Paleo Lake in northwestern Sudan, a very large lake I will come back to, where you usually find deposits like this, the same diatomites, which are lacustrine record of the Holocene, and normally it's hardly ever has a thickness of more than 3 or 4 meters. That means normally excavator is much better than cores, which we have just 8 centimeters of core material, but here you can go down, you can look for datable materials, that's the charcoal. So that's what we essentially did, digging holes all over the Sahara. A very strange sight for many of the Bedouins before we go into the desert, seeing us going through the Sahara with excavators or even with rubber boats. So for the archaeology, it's a very tedious work. It can take weeks in the sandstone from morning into evening. Just this excavation of a few square meters can take weeks in the worst case. So that's a very, very time-consuming job, but it allows to reconstruct much of the former life of the people, even to reconstruct single artifacts like this, which tell you everything about the person who did it, or excavation of one single early Neolithic grave can take more than 1 week for 2 to 3 people in these remote places. And of course, there you need lots of time and lots of patience doing such work. The same as the reconstruction of the former fauna in the Sahara, like this jaw of an elephant somewhere. It can also take at least 1 afternoon just for one single sample. And the whole sense of it is then looking how the climatic change influenced the environmental change and what repercussion that had on the former way of life, on the economy, and again in the last stance on the cultural change in the Sahara during the past 11,000 years. So I just give a few examples of some highlights on the Sahara. One comes from the Gilf Kebir plateau in the southwestern part of Egypt. And there you see, if you take away the sand with radar images, you see that what looks today as an area completely covered by wind-blown sand. In fact, there's large drainage systems underneath, just 1 or 2 meters below the surface. And this is in this one example from here in the western part of the Gilf Kebir, where some may have seen the English Patient, the film, which is, of course, this was done in artificial cave in Hollywood and mostly in Tunisia. It's not the real site, but the real place is here, and you see you have 2 unimogs for scale at this place, where even in the 1930s, one of the first expeditions there by Al-Mashi and Frobenius and our predecessors, Hans Rothart, who discovered this rock art of the so-called cave of swimmers with some persons who seem to swim. There's other interpretation, but to swim you need water. And in fact, there were many places in the Gilf Kebir, as evidenced by geological details. Again, that's one of the box canyons in the Gilf Kebir plateau, 2 unimogs for scale. So this is almost 1 kilometer wide. And again, this should have looked what concerns the water cover like this in the early Holocene. These were playa lakes, which were filled by rainfall and which subsisted for a few weeks or months. There was no permanent lakes until they disappeared. And they were blocked by this blocking dune, which was much higher here. That's why you get a unique record of these kind of playa deposits. And you see here that's just part of 50 radiocarbon dates we have from this site, about 8.5 meters. And this has a very detailed bedding, and you see lode cars. You may always have a sandy layer and a pelitic, very fine grade layer. And this is evidence of the major precipitation event, major rainfall events in this core of the hyper-arid eastern Sahara, where each and every single major secular rainfall has been recorded in this, and it would need lots of more dating. implying the destruction of the site, and then you could date each and every major rainfall in this place, which today receives less than 2 millimeters of rainfall. But it's not only the quantity of rainfall and the frequency of rainfall, of course, and of course, there's always no time to go into detail, but comparing the archaeological record and comparing the geological record, we found out that it's more important at which time of the year there was rainfall, and it's more important what kind of rainfall it was. So it's not the quantity itself, and comparing well the distribution of sites on the plateau and in the floor of the wadis, it shows that apparently the much more substantial monsoonal summer rains, which normally fall torrentially during the daytime in summer, they have much less impact on the vegetation cover than have much less important sort of westerly Mediterranean type winter range, which normally fall during the night. That means they are much better available for the plants, and this can explain why in the later period, where we have much less rainfall compared to the early Holocene, but there were many more cattle herders grazing the animals on the plateau than there were during the monsoonal period. So that's one important aspect. Another major site is in northwestern Sudan, which was hardly recognizable on the old Landsat imagery in the early 80s. But if you go there and you take away the sand cover, most of it is covered, then within 10 minutes you can make a big collection of fish bones of a Nile perch up to almost 2 meters long, and hippo and crocodile and so on, including water tortoises, which are completely preserved. And this all led us to believe that, in fact, what we call the West Nubian Paleo Lake corresponds to the Ptolemaic marshes of the tortoises, which should have looked, what looks today like this, should have looked like this, like present-day Chad, a very shallow but very large lake, which looks today at its former shoreline, and you hardly see anything like this. But then you go into detail, you find even burials of cattle, you find lots of archaeological material and datable material, charcoal and so on. So again, this place should have looked like this, like present-day Lake Chad, if you take a boat and go in this very shallow lake. There's many similarities, and just to show you that this big lake shrunk, that means in such places like rivers, like lakes, usually the Neolithic, an apostrophe, Neolithic population, prehistoric population, normally arrived later with a lag time which rates between 500 to 2,000 years. That means when the lake was the biggest, there's relatively little archaeology, very old pottery, dotted wave line, etc. And only during the later period, when the surrounding environment became too dry, people had to approach to these rivers, to the lake shores, which before were much too humid, much too wet, much too dangerous to live in. So that's one example. And the last example from Wadi Hawa, which used to be the largest tributary to the Nile, more than 1,000 kilometers long, and the lower part was completely unknown when we started in the late, in 1980. And in fact, it found out, as you hardly see anything, at least at the existing Landsat data available in the early 80s. In fact, it was a 400 kilometers long wadi, not a permanent river, but an episodic and later even a sporadic water flow, but up to 10 kilometers wide. That means during the early Holocene, it must have almost rivaled the Nile Valley, and there's more I could talk about it, but apparently at the beginning of the early Holocene, it must have been a paradise where you had people, round-headed people. That's probably the most ancient rock art of Egypt. In between, peacefully, like we do in this session here, between herds of rhinos, which usually are solitary people, though really paradise situation, apparently, who used to live on the banks of Wadi Hawa in the beginning until, and then late it dried out. And just again, this photograph, that's what it looks. You see some windows of lacustrine deposits, but usually you see nothing but this, so you can drive over it without noticing anything. But 7,000 years ago, people drowned apparently in the deposits in a place where today hardly a scorpion can survive, and you have rainfall of less than 20 millimeters again. So if I have a situation like this, you dig a hole and you drive in. This was almost 8 meters deep, exceptional rate of deposition. So this should have looked like a situation you find today in western Darfur, in northern Kordofan, 600, 700 kilometers further south. And it goes into the species of the tree, which we found here. So that's no fantasy, but that's proof. Also, you found evidence in freshwater oysters, which give information on the annual humidity. And Paul Abel at the time, that's how it looks today, but these are high energy deposits, several major high energy events. And there's, for example, this Seria elliptica, which occur only in very fast flowing water. And doing isotope there was surprising information that there may have been 2 humid periods per year. That means not one, and at a relatively late period. I mean, that's still a bunch of information which has not been harvested so far, but according to it, and of course, if you had a peak rainy season, this has implication for the entire rainfall regime at this relatively late period, well, until 7,500 years ago. So again, archaeology, it's a nightmare. Never 1 per mil of 1 per mil will ever be studied. These are the largest prehistoric sites in all of northern Africa. It's much, much more important than along the Nile Valley. These are squares, kilometers large site, and each and every piece you find on this dune consists either of pottery, of bones, etc. So digging just 5 square meters takes 1 month. So it will never, ever be collected fully, and there's plenty, not such big sites everywhere, but all around here they are comparable, and they are scattered all over what is today, well, the extreme part of the Sudanese Sahara. And so this provides just one example of several regional reconstructions we did. That's just showing how it changed from an intermittent wadi river with very demanding megafauna, then slow desiccation of the lower part of the lower 400 kilometers of Wadi Hawa, until this was no more place to live, and people moved up valley just to get more rainwater and ways for living. And so summing up the geoarchaeological very far, that means, say, 15,000 years ago, there is not a single prehistoric site in all over this region, which covers more than 2 million square kilometers. That's Western and Central Europe. Not a single site. The only sites known are in the Nile Valley. And this changes completely when around 11,000 years ago there was a very sudden arrival of rainfall from the south, which changed the whole pattern. This is very schematic, but it gives an idea. That means within a few centuries, 500 to maximum 1,000 years, you find sites all over the Eastern Sahara. That's not all, that's just a major one, while there is almost none in the Nile Valley left. That means a complete shift of vegetation there and there, and you can already see that in the southern part there's few sites, apparently because it was too humid to live there. So we are in this section, and you see there's a relatively fast occupation at that period, say 10,500 years ago, where except in the south there were people everywhere. Not many, but they were. And this stayed for, say, around 2,500 years, 3,500 years, depending if we talk about this region or this region makes a difference, but say roughly a few thousand years and so on, where people were really settling everywhere in a large part of the Eastern Sahara, and again, not a single site along the Nile Valley. And then there was some influences from the Near East, Southwest Asia, but that's another topic. So again, you see there's a maximum, and this is based on now up to in between almost 1,000 archaeological radiocarbon date and more than 1,000 geological date. You see there was establishment of these people all over the Sahara, maybe except in the south. And then 5,300, that was really the major date in the history of the Eastern Sahara, where that was the beginning of the desiccation of Egypt, not of Sudanese part, but from Egypt, where there was a slow trend towards aridification, to desiccation of the Sahara, which lasted until 3,500 BC. And that meant that people had to return to the oasis, or they had to move south. And now you see in the later period, there's plenty of settlement further south, in contrast to before. So you see this stage shows very clear a trend of vegetation. All these later sites, these are all sites which... I'll go back, I leave it, which of ecological niches, like high plateaus in the Gulf Kabir, or along exotic rivers, like some wadis in the period. That means, and later, after 3,500, you have practically nothing left in the Sahara, while the entire Nile Valley it's thousands and thousands of sites. Most are destroyed by now, but I mean, you couldn't draw all the points here. And that was exactly more or less the time of pre-dynastic and the origin of pharaonic situation. Again, that's where we are here in the north. There's nothing, while the south, there's still some settlement until, say, 3,500 years ago. And that's some anticipation about what I'm talking now, that probably, well, this was this abrupt change. And here you see the comparison. Well, it took some 2,000 years, but first you had a settlement distribution like this, and later you only had some oases and ecological niches left, nothing more in between. And of course, that's another interesting story. So later, the first trans-Saharan Africa and ventures, pharaonic ventures into the desert. So again, in putting it all in one graph, and there's many more points in between than this publication, you see a clear trend. You say a relatively fast onset of occupation, relatively fast, not decades or century, but say 500 to 1,000, or settlement all around. And sorry, does it go back? Yeah, exactly. And then a very slow migration further south to where the people are still today in sub-Saharan Africa, in northern Darfur, and that's most biggest part of the problem, and not what George Clooney talks about. Anyway, so again, you have the fold drift. You have a Sahara, which once was maybe 1/4, 1/3 larger than it is today. We are far. We haven't reached the maximum extension of the Sahara during the last glacial maximum, which reached several hundred kilometers further south, and then a relatively fast change into in a rainfall area, then the constant settlement some millennia, and then a very gradual retreat. And these are the isohyets which you can see to the present, where the southern Saharan border is here, while it used to be here, or practically there was hardly any hyper-arid desert left. And now these were, there were archaeological data. 10. Okay, I have to hurry up a bit. So now we look, and this is a distributed, many sites, well distributed, but usually geologists, they prefer permanent, continuous record for all kinds of analysis. And I remember Wally Broco more than 20 years ago I said, well, he said, well, there is no terrestrial record, so we have to use the marine data. But luckily, 20 years later, we have advanced a bit. So we are going to Unyanga, which is in a hypercontinental situation. That means it's very representative for this part of the desert, because it's very far from the ocean. They don't have any immediate oceanic input, so it should give clear data. It takes a long, even just the field work implied almost a year of field work just to get the material there to work. So it's a very remote place, and we were lucky that we could do it. But after driving 1,000 kilometers through hyper-arid desert, which looks like this, and you're advancing 2 meters, and then opens up an inland sea, which is really in this way unique on Earth. It's the largest lakes by surface and the largest by water volume. There's even freshwater lakes in these places, which are paradox in hyper-arid environment normally, where the water gets salty within a few years. And you find toads and fish and freshwater fish and mollusks, the direct descendants of the early Holocene mollusks which were settling there. The lake level was much higher. You mean some few remains on top of the surrounding plateaus, like here, which indicate that the lake level was about in Unyanga high, 100 meters higher than it is today. They had a large drop during the early Holocene. And no time to go into this unique system to have freshwater lakes, and this just works through the system of an evaporation pump, which draws the fresh water before it can get salty, and that's why this mechanism, which is really, I never heard about anyone proposing another site, is really unique on Earth. But for geology of a paleoclimatology like yours, it's the most important. That's the largest body of water in the real Sahara. We're not talking about some lakes close to the Mediterranean, and it's some 3 kilometers north-south direction. That's what I've shown before. That's Lake Yoa, and that's an aerial view where you see the encroaching dunes. So it's just a matter of time that this lake will disappear. As all the other thousands of paleo lakes which once covered the Sahara. Many of my French colleagues from Pierre Rognon and Nicole Petit-Mer and many others who were studying already in the 70s and 80s. But this will disappear, but there's still a few thousand years ago. And besides science, because normally our partners or our hosts in Africa, they are not that much interested in paleoclimatology yet. So I've been working for almost 15 years to get these lakes listed as the first Chadian World Heritage Sites. That's why we got a medal from the president, whom I might see tonight, because he apparently will arrive in Paris today for the next proposal for the Enity Mountains, but that's another story. So if you want to read more, you can order for free this worldwide distributed Saudi World magazine. You just can order it. You can either see it on the internet or you order it for free, and you get it for 2 years if you prolongate it. So there's some more on this aspect. And now we're coming to the major thing. When I took the first core in 99, big surprise, it was undisturbed sediment. That's the top of the floor at a 26-meter deep lake floor situation, and you see one layer, and of course there was hope that it continues. And after many months field work more, well, this gave a first synthesis in science, where you see a gradual change based on the palynology on the pollen, which were mostly done by Anne-Marie Lessine, and which show more or less a really gradual change from sort of tropical demanding species towards semi-desert, Sahelian, finally to desert situation. And if you compare it with Peter's epic, famous core, of course, there's some difference. And so, well, according to our data, terrestrial data, it should go like this and not like this and then this. But that's for discussion. So, and one of the what the conclusions is that, say, around 2,700 years ago, the Sahara became more or less how we know it. There was a little bit more rainfall, but compared to today, it was very similar to the situation today. Since then, not much has changed. And the study of this, detailed study, and by Pierre Francus, mostly, it showed that in the upper corner, 6,200 years, there's not a single year missing. I mean, how could it? Because it didn't dry out, but it gives, you have every year 2 layers, sometimes even more, as I will see. That's why we returned into 10 for coring using a UV-Tech platform. It was hard work, and in the end, we had to be protected by some soldiers. That's also another story. You see, that was the older core, that was a new core reaching the bedrock sandstone here, and that's how the entire core looked, and it's mostly laminated, subannually laminated. I could show you now all the 16 meters. We leave it like this. It's really usually 1 to 2 millimeters per year. And most it's really, you can count, you can establish, we have established a vast chronology. There's these white spots are being filled. That means if you're applying other methods, microscopy, thin section, you find much more. And this ended up in this age model, which shows that you have real organic material, which sometimes took a week just to collect one sample. And they are very well corresponding with the now 3.5 WAF counts, which have been done, a very tedious work covering the past 11,000 years. While you see the radiocarbon date, and that was Edouard was explaining before, they are off up to 2,000 years because of the hard water effect and the reservoir effect. That means Alone with nothing but this graph, we can recalibrate practically all the 1,000 geological data we have from paleo lakes all over the Sahara, because, well, they were wrong. That's why I was doubting for a long time the 8.2 event, because I say, well, it might be there, but we don't find it in our records. Once we apply this correction, the whole situation looks different. This would be good for a couple of PhD studies. And now comparing it to the few records on the African continent today, even the first, our old core, short core, was top for Africa, and now the long core, it's absolutely the top. And if you compare it to all other WAF records, I mean, to cut it long story short, unless someone of you presents me the more information, but it looks like it's the longest Holocene WAF sequence worldwide. If you go into detail, Clade is comparable but starts 500 years later, others. So it's a big potential, but it's an endless work. We have much, much more than 20,000 single layers to be studied. I would need tens of specialists, which I don't have. So no time to go into detail with the several zones where you find lots of interesting sedimentological, geochemical data. The same, just to go into detail, would need probably at least 20 minutes. So I leave it with this, and I go just, say, interpretation from the geochemical data, which you can read that there was an initial phase which took quite some time to establish this up to 80-meter thick lake. Then apparently only later, after 9 to 7, we had, according to the geochemical data, we had this wet peak, and later it turns increasingly saline until more or less you saw there's an onset of really distinct dust input from everywhere until 4,000 years. That was, according to the geochemical data, more or less the establishment, the beginning of the present-day lake situation. What's that? No, that was gone. And based on this data I've shown before, where we have all kinds of diatomines which are exposed high above the present-day level, which again are annually layered in some places. So this is for the future, comparing them to the sub-bottom sediment on the bottom of the lake. You can, we tried some virtual flooding. That means that's about more than the present-day extension, and that's about today 3 kilometers diameter. That's a very conventional estimate or model. That means the lake once was at least 30 kilometers in diameter. That means up to 50 times larger. There were more lakes around which have disappeared because of the dropping lake level. And of course, this is crucial for the interpretation of the sedimentological geochemical data, because it makes a big difference if the shoreline was very close or it was very far. And so, and that's a big puzzle which we are dealing now, and which took many time. Luckily, there are very sometimes more easily interpretable data biomarkers like Florence Silvestre's also maybe world record of diatom count on this core, and she will come back to it, so I may skip it, but which also shows very, very interesting events based on the biomarkers, and especially, of course, the 8.2 event, which occurs in almost any data we have from this core, and which we can get date more precise than in many others. For the terrestrial environment, that's the pollen, of course, and very, very preliminary data. They indicate already this situation that first you had an onset of, say, approaching formerly southern sub-Saharan vegetation in the lower part, but it took a long time. It took here until, can you read it, 9,600, until only there was a rising, more or less demanding tropical vegetation, tree vegetation there. This took time until Combrataceae, for example, became abundant. This took some time, and that's, of course, indication that there was no abrupt onset, but also very relatively slow until the establishment of more humid terrestrial environment during that period. And then there was again this dramatic drop in the lake level, and increase of reeds like Taifa and so on. Afterwards, you have lots of grasses all around, so the big trees disappeared. So this has impacted this really hypercontinental Lake Lua region dramatically, until there was a slow return of more humid condition and so on. And this went on until, again, that was the beginning more or less around the 5,000-6,000 years ago. There was the onset of this slow drying in the lake region. And now I just selected another biomarker by a colleague of mine, Monsieur Schefus and Janet Rettemeyer and so on, which in comparison to the recent data by Cestiani and Peter, again on the C3, C4 and C4, well, that's more grasses, that's more trees, to cut a long story, complicate so short, but the data, the preliminary data, they indicate a very gradual decrease of these curves towards the present, and again, no indication of anything, say, too abrupt. And one of the conclusions of one poster we had at the recent EGU, you can see that there's again a more gradual shift, which is again in contrast to the marine data from the Gulf of Yemen. And I don't know how much time do I have? It's over. Okay, I'm finishing. So maybe you can fly over this graph. I don't have to read it. Everything we had, say, 11,000 years ago, increasing rainfall. Most of the rainfall came from the south, from the Gulf of Guinea, crossing the Sahara because the global warming at the period, and you had increased evaporation over the ocean, and this water vapor was brought deep inland driven by paleo monsoon at the period up to north of the Tropic of Cancer, some 800 kilometers further north than today, of course controlled by the shifting of the ITCZ, which Edouard has shown before, and this changed relatively rapidly. The former hyper-arid desert, which existed for more than 80,000 years, into a very diverse savanna environment, which was fully populated and which was spread by thousands and thousands of lakes and wadis all over, and which allowed reoccupation by humans after almost 100,000 year long break. And then there was this 3,000 years relatively stable condition where people stayed there until 7,300 years ago. They started migrating south because you have no chance. If there's no more rainfall, you don't reach the subsurface, near surface groundwater. Either you stay and die or you move. I mean, there's no big question. It doesn't make a big difference. In Somalia, you have 400 millimeters and there's a shift to 350 millimeters. This doesn't change. But if you have 100 millimeters and then you have none, this makes a change. And that's why we use humans as a very sensitive paleoclimatic indicator, which used to roam everywhere, and I would say which is an important data set. And then there was the southward movement, and mobility was the key to survival. And in the end, I think with my archaeological colleague, it's no pure coincidence that exactly when the Sahara became too dry to live in, that was the emergence of the Egyptian and Sudanese civilization. So I think there's a direct climate control of all this cultural change. And now for discussion tonight, compared to Peter's and others and his whole team for the past 15 years data, maybe we can talk about the extent of the African humid period. I mean, Africa is a big continent, even bigger than 3 times bigger than the Sahara today. The timing, at what are we looking? In which latitude? Do we talk about the equator? Do we talk about Tropic of Cancer? Do we talk about the Mediterranean coast, which makes a big, big difference? And of course, the causes. How to explain abrupt causes without volcanic eruption, without meteorite impacts, without nuclear catastrophes? It's difficult because there's few even no, at least for the quaternary, paleoanalogues, which you could use for comparison. And of course, Martin will forward also models how to explain it. There, I hardly understand except the results. And so again, so what was claimed in Peter's first epic paper, 14,800, and we see that it took, well, after the Joa core, almost 2,000 years until it really became wet. And the same thing, there was no abrupt at 5.5, but rather it took several millennia to reach the present-day situation. And so that's to come back to my introducing slide. So it's a big discussion of the validity of marine data, even if they're very close, even if they come from the Indian Ocean, from the Mediterranean, from the Atlantic Ocean, but are they really indicative of the climate on the continents where people used to live and will live probably forever? And would be a list with hundreds of names, so just leave it with this one, thanking all the institutions and my colleagues. I had the luck to work in this paradise of fools of the Eastern Sahara during the almost 4 decades. Thank you very much.